Light, it illuminates our world, bringing clarity to the darkness and revealing the beauty of our surroundings. From the moment the sun rises, casting its golden glow over the horizon, to the twinkling stars that dot the night sky, light is an ever-present force in our lives. It paints the sky with vibrant colors, creating breathtaking scenes that inspire awe and wonder. The warm hues of a sunset, the ethereal dance of the northern lights, these are just a few examples of light's artistic touch. Light travels at an incredible speed, the fastest thing in the universe. In just 1 second, it can cover nearly 300,000 kilometers, a speed that boggles the mind and defies our everyday experiences. Almost 300,000 kilometers per second. To put that into perspective, light could travel around the Earth 7.5 times in just 1 second. This extraordinary speed is what makes light such a powerful messenger across the cosmos. That's 7.5 times around the Earth in a single second. This incredible velocity allows light to bridge vast distances, connecting us with the farthest reaches of the universe. We see the moon because light reflects off its surface. This reflection is what makes the moon visible to us, a glowing beacon in the night sky. We see distant stars from billions of years in the past. The light from these stars has traveled across the vast expanse of space, taking billions of years to reach us. When we look at the night sky, we are essentially looking back in time. Light carries information across vast distances. Whether it's the light from a distant star or the data transmitted through fiber optic cables, light is a powerful medium for communication. But what if we could control this cosmic messenger? What if we could harness its speed and precision for our own purposes? What if we could slow it down? Scientists have already made strides in this area, using various techniques to reduce the speed of light in controlled environments. Could we even stop it entirely? Imagine the possibilities if we could bring a beam of light to a complete halt. Imagine freezing a beam of light, holding it in your hand. A mind-boggling concept that challenges our understanding of physics and the nature of light itself. Freezing light would be like stopping time itself. It would open up new realms of scientific exploration and technological innovation. It would allow us to examine light's secrets up close, to understand its properties in ways we never thought possible. The cosmic messenger holds many mysteries, and as we continue to explore its potential, who knows what incredible discoveries await us. When we talk about freezing light, we don't mean cooling it down like you would a cup of coffee. Light doesn't have a temperature in the way that matter does. Instead, we're talking about slowing down light's speed. Ideally, slowing it down to a complete stop. This might sound like science fiction, but it's an area of active research. Scientists have already been able to slow light down dramatically. One remarkable method involves using something called a Bose-Einstein Condensate, or BC. A BC is a state of matter created when atoms are cooled to near absolute zero. At this extremely low temperature, the atoms act in unison, behaving like a single entity. When light passes through a BC, it interacts with the supercooled atoms. This interaction causes the light to slow down significantly. In 1999, scientists successfully slowed light down to a mere 17 meters per second using this technique. That's slower than a bicycle. Another way to manipulate light speed is by using photonic crystals. These are materials with a periodic structure designed to interact with light waves. Imagine a microscopic structure of tiny mirrors, carefully arranged. These mirrors can reflect and redirect light in very specific ways. By manipulating the structure of the photonic crystal, scientists can control the flow of light within it. They can slow it down, trap it, or even redirect it at will. Section 5. Light on a chip, revolutionizing computing and communication. The ability to control light speed has mind-blowing implications for technology. Imagine computers that operate at the speed of light. This could revolutionize fields like artificial intelligence and data processing. Optical communications, already faster than traditional electronics, could become even faster and more efficient. This would lead to blazing fast internet speeds and seamless data transfer. Light-based circuits could replace electronic circuits, leading to smaller, more powerful devices. Imagine smartphones thinner than a sheet of paper or incredibly powerful quantum computers that fit in your pocket. Section 6. Imaging the infinitesimal, unlocking new frontiers in microscopy. In the ever-evolving field of scientific research, microscopy stands as a cornerstone, enabling us to peer into the hidden realms of the microscopic world. From the discovery of cells to the intricate details of molecular structures, microscopes have revolutionized our understanding of biology and materials science. Freezing light would also be a game-changer for microscopy. Imagine a world where we could manipulate light to such an extent that it reveals details previously thought impossible to observe. This concept, though seemingly out of a science fiction novel, is becoming a tangible reality thanks to advancements in photonics and quantum mechanics. Current microscopes use light to illuminate tiny objects, but there are limits to how small an object we can see. The resolution of traditional optical microscopes is restricted by the wavelength of light, which means that objects smaller than approximately 200 nanometers are difficult to resolve clearly. This is due to the diffraction limit, a fundamental constraint imposed by the wave nature of light. When light waves encounter an object, they bend around it, causing a diffraction pattern that blurs the image. This phenomenon sets a hard limit on the resolution of conventional optical microscopes. By slowing down or stopping light, we could potentially bypass this limit. Techniques such as super-resolution microscopy and the use of quantum dots are already pushing the boundaries, allowing scientists to visualize structures at the nanoscale. These methods involve manipulating the properties of light and its interaction with matter to achieve higher resolution. This would allow us to observe objects at the nanoscale with unprecedented clarity. The ability to see such minute details opens up new possibilities in various fields, from medical diagnostics to materials science. For instance, researchers could study the behavior of individual proteins within cells, leading to breakthroughs in understanding diseases and developing targeted treatments. Imagine being able to see individual molecules, viruses, or even the intricate workings of DNA in real time. This level of detail could revolutionize our approach to studying biological processes, enabling us to observe the dynamic interactions that underpin life itself. The future of microscopy holds the promise of unlocking new frontiers, revealing the unseen, and expanding our knowledge of the microscopic universe. Section 7, Quantum Leaps Light and the Future of Computing. The world of quantum physics is full of strange and counterintuitive phenomena. One of these is quantum entanglement, where two particles become linked. They share the same fate, no matter how far apart they are. This spooky action at a distance, as Einstein called it, has puzzled scientists for decades. Controlling light's speed could be the key to harnessing entanglement for practical applications like quantum computing. Quantum computers would be exponentially faster than traditional computers. They could revolutionize fields like medicine, materials science, and cryptography. Section 8, A Window into the Universe. Exploring the cosmos with frozen light. Freezing light could also revolutionize our understanding of the universe. Imagine being able to capture a moment in time from a distant galaxy and study it as if it were right in front of us. This concept could open up new avenues in astrophysics and cosmology, allowing scientists to delve deeper into the mysteries of the cosmos. Telescopes rely on light from distant stars and galaxies. These powerful instruments collect and magnify the faint light that has traveled across the vast expanse of space, bringing into focus celestial objects that are otherwise invisible to the naked eye. The light we see today from these distant sources has been on an incredible journey, traversing the universe for millions or even billions of years. This light has been traveling for millions or even billions of years before it reaches us. Each photon carries with it a story from the past, a snapshot of the universe at a different point in time. By studying this ancient light, astronomers can unlock secrets about the formation and evolution of stars, galaxies, and even the universe itself. By capturing and analyzing this ancient light, we can piece together the history of the universe. Every image, every spectrum, every data point adds to our understanding of the cosmos. It's like assembling a giant cosmic puzzle where each piece provides a glimpse into the grand tapestry of the universe's past. If we could slow down or freeze light from distant objects, we could study it in much greater detail. This would allow scientists to examine the properties of light with unprecedented precision, revealing new insights into the physical processes that govern the universe. It could also help us understand phenomena that are currently beyond our reach, such as the nature of dark matter and dark energy. This would give us a clearer picture of the early universe, the formation of galaxies, and the nature of dark matter and dark energy. By freezing light, we could essentially pause the universe and take a closer look at its most fundamental components. This revolutionary approach could transform our understanding of the cosmos and pave the way for new discoveries in the field of astrophysics. Section 9. The future of frozen light, a universe of possibilities. The ability to freeze light is a tantalizing prospect with mind-blowing implications. From revolutionizing computing and communication to unlocking new frontiers in microscopy and medicine, the possibilities are endless. As we delve deeper into the quantum realm and continue to push the boundaries of science, the ability to control light could unlock a universe of possibilities that we can only begin to imagine. The future is bright, and with the power of frozen light, it's about to get even brighter.